P of x is a quadratic, so we can factor it as x minus r and x minus s, where r and s are the roots, solutions where P of x is equal to 0. That means when P of x is equal to 0, this can be factored as P of x minus r times P of x minus s, and this product is equal to 0, which means we have P of x is equal to r, or P of x is equal to s. This P of x has 3 solutions. So let's say we get 1 solution from this equation and 2 solutions from this one. If P of x equals r has 1 root, then the discriminant is equal to 0. Let's replace P of x with x minus r times x minus s. And let's expand this so we can find the discriminant. So b squared minus 4ac is equal to the square of minus r plus s minus 4 times rs minus r, and we want this to be equal to 0. Expanding and combining terms, we recognize these first 3 terms as the square of r minus s, and this is equal to minus 4r. Taking the square root, we have r minus s is plus or minus 2 times the square root of negative r. This p bar of x is the version of our function that has a maximum sum of the roots, so maximizing r plus s. We'll solve the above equation for s. So r plus s is r plus or minus 2 times the square root of negative r. To maximize, we'll add 2 times the square root of negative r. So this ends up being 2r plus 2 times the square root of negative r. Now we find the value where this expression is maximized. To see that more clearly, we'll let a be equal to the square root of negative r, which means a squared is negative r, and r is the negative of a squared. So we'll substitute and factor negative 2, and we'll complete the square by taking half the coefficient of a and adding it inside the parentheses. This is the same thing as subtracting 1/2, so I'm going to add 1/2 out here. We see this achieves its maximum value when a is equal to 1/2. Now we'll go back and calculate r, squaring both sides, and r is equal to negative 1/4. S again is r plus 2 times the square root of negative r. So that's negative 1/4 plus 2 times the square root of 1/4, or 3/4. So we can write p bar of x as x minus r, x minus s, and substituting our values for r and s, that gives us x plus 1/4 and x minus 3/4. The problem asks for p of 1, so we'll substitute. This is 5/4 times 1/4, which is 5/16, and that is option A.